Hello and welcome to our Connection Wednesdays webinar. The title for today is From Grouping to Delivery, Simplifying Steel connection design. Oh, that doesn't work. My name is Stefan Jurat, and with me is my colleague Maciej Kraski. He will present the topic to you today.
Hello, Steffi. Great to see so many IDEA StatiCa enthusiasts again joining our session. Yeah, I'm happy to talk about all the topics that we prepared for this session. So let's start.
Thank you, Maciej. I will just introduce shortly our webinar panel to you. If you have any questions, you can put it in there. Our colleagues will collect and answer them for you. At the end of the webinar, we will have a short Q&A section where Maciej will answer some questions. If there are more, then he can answer. We will get back to you and answer all your questions afterwards. So you're all in muted mode, and you will stay the whole webinar. So all the questions, please enter in the panel. And with that, I will give back the word to Maciej, who will start presenting.
Thank you, Steffi. I will share my screen now, and we will turn off our cameras for this part. And let me start with the agenda of today's webinar. So yeah, this is a highly practical webinar session highlighting the most recent development of our software that will enhance your structural engineering workflows. So the idea behind it is one quote that I read lately, like, don't automate engineering, automate the tasks that steal time from it. So I hope that with this session, we'll be able to address these tasks that are stealing the time from the engineering, the creative part of your workflows. So we start with a brief introduction, then proceed with the description of the workflow in IDEA StatiCa Checkbot. So we will work mostly in this program, but we also will touch a bit on IDEA StatiCa connection, and we'll be talking about topics like node grouping, load extremes algorithm, bulk workflows, IFC model with connections, so exporting your designs to an IFC file. And at the end of it, as Steffi mentioned, we'll proceed with a Q&A session, and hopefully at the end of the session you will get more knowledge of what is possible in our software, and that you will be able to do more in less time. Yeah, so here's a typical workflow. We are starting with our global model in FEA software, which then can be transferred, so you can export the data, import it into Checkbot. There you can adjust your model a bit. You can also choose which loads you'd like to take into account in the design. You can create groupings, and then this data can be passed on to connection where you can proceed with modeling. And for this session, we will be concentrating on step 2 and step 3, which means we are not talking about how to import data from FEE software. If you are interested in this topic, please refer to our support center, where you will find tutorials for all supported integrations. There you will find a detailed instruction of like step-by-step tutorial how to import data from your software. So as I mentioned, we start with a pre-imported structure. And here is the project, yeah, that we will use for our presentation. I wrote out here just a few information for you. So this project consists of 158 nodes, which we grouped, for which we create 15 groups. The group consists from 3 to 36 nodes. And in this project, I created 60 load combinations. Yeah. I'm talking about this data because right now we would like to ask a question. Yeah. So how long would it take you to design the connections in this project? Yeah. So this, by design, I mean you need to model the connections, you need to run the calculation, and then create a report for that. So please vote and tell us how much time would you estimate for such a project, because in the end I will show you my estimate how much time it took me to do all these tasks for this project. So I see that like more than 50% of you have already voted, so we'll wait another 20 seconds to see. Yep, 10 seconds left, and then we can have a look at the results. Okay, so we can see right now the results of the poll. So 21% of you, so let's say that it will be around 1 day to do it, then another 18%, 1 to 2 days, and more than, so around 60%, 2 up to 3 up to 4 days. So yeah, let's proceed with my presentation, and we'll go back to this question later on. So talking about workflows, yeah. First of all, we are working here with IDEA StatiCa 25.0, the latest version, latest patch, and here I wrote down this workflow step by step. Of course, this is like a general workflow. You can always adjust it to your needs, to the way how you are cooperating with external offices or internal colleagues. So yeah, this is just to give you an idea of what is possible in the software, to give you a good overview of that. So we are starting with creating or editing node groups. So these groups, which what you will see, are automatically generated once you import the data to a connection. But as it always is with algorithms, you should take a look if the groups are looking fine, because sometimes you need to regroup them, and this is why you have full control of what can be done with within a group. Then you proceed with step number 2, which will be modeling the reference node. So this is also an important thing, that for a group we are setting a reference node, which we'll see in short why it's so important to have it defined. Then we'll evaluate critical load effects, so also to reduce the workflow here. As I mentioned, we have 60 load combinations defined for this project. You will see how much we'll have once we activate this algorithm. Then we're ready to run a calculation for nodes in a group or for single nodes, because that is also possible. Then we'd like to take a look at the results and verify if everything's correct there. Then we can create report or reports, however we want, and share connection design if we've adjusted it. And here we'll have a look at 2 options. Either we can prepare an IFC file, or we can share the data via a free cloud tool called IDEA StatiCa Viewer. So let's start with point number 1, like dynamic node grouping. So after import of multiple nodes from your software, nodes are first sorted into arrangements based on their geometry. I will talk about definition of arrangement in a moment, so don't be scared by this term. Then groups are created automatically based on that, and then for each group a reference connection is set. So before we will jump to Checkbot, let's have a look at the difference or the definitions of typology and arrangements in Checkbot applications. So typology takes into account number of members and orientation. So you can see here different typologies, 1, 2, and 3. Yeah, the difference, for example, here between 1 and 2 is that here we have like a continuous member, and here there is an ended member. That's why we have 2 different typologies here. And then the arrangements are created based on the cross sections in that node. Yeah, so we see rolled I profiles here. Here we have hollow profiles, and here different hollow profiles. That's why we are creating here 3 type of arrangements: 1, 1, 2, 1, 3, and the same applies to the other 2 typologies. And right now, I'd like to jump to the software so that we can have a look at how it looks like in real life. So this is this project that I imported. As I mentioned, around 160 nodes have been imported with 60 load combinations. We also can have a look at all of them here. Yeah, so in the load configurator, I see that all of them have been correctly imported. And as you can see here in project 3, we see the arrangements and the automatically created groups. Yeah, group 1, group 2, group 3. If I click on the group name, I see that the 4 nodes have been highlighted here. Yeah, so these are the nodes that are part of this group. And as I mentioned, the groups are created automatically. But for example, we may say that for these 2 nodes, we have, because this is an anchoring here, so we will have different edge distances than for these 2 nodes. So in this case, we can just create a new group. How to do it? First, let's just change these 2 nodes. They are part of group 1. Right now, I'd like to assign them to no group, so they are part of no group right now, and we can create a new group here. So I select node N73, and then I can create a new group here by clicking on this button, and you can see right now I created group number 13, which of course can be renamed. Maybe I better say it's 1.1, and then I will add node 75 to this group as well. And as you can see, right now I have edited this group, so created a new one, and right now I can have different edge distances assigned to these nodes. So this is how you create new groups. And one other thing that we mentioned are the reference nodes. Yeah, so for each group there is a reference connection. For group 1, this is the connection N1, and if you click on this button, then this connection will be highlighted here in the 3D scene, so that you can notice right away which node is the reference one. And why it is important? It is important because all settings like model type, forces in, code setting, as well as all the operations that you define for these nodes are automatically propagated to other nodes. So let's just proceed with the second point, so modeling the reference node. And here I will just take group number 8 as an example. For this group, I have prepared a template that I will use. So let's just jump to this group. You can see these are all these frame corners that are highlighted in the scene. And for this group, the reference connection is node N153. So I can just click here to highlight this node, and yeah, this step includes modeling. So right now we will open this node in Connection app. I'll just click here on open and start the Connection app so that I can there add the operation. So yeah, here we also have different workflows. You can either do it manually, so add the stiffening members, add the stiffening plates, welds, and so on and so forth. Or you can also use like a library, connection library that you created for your company, for example. And this is what I will do in here. So we see that these are the 2 members that are part of this node. All the 60 load combinations are listed here. And as I said, what's missing here are the operations. And instead of modeling it manually, I will use a template that I have saved in the connection library. So here I click on the propose button so that the software can show me a list of all templates that are applicable to this geometry. And for this node, I select this template that I prepared before our presentation. And here I can also specify the materials and bolt assemblies. So if I'd like to use different bolt assembly that has been used in the template, I can change it here, but I will stick to the M20 10.9 bolts and just click OK. And you see that right now the operations have been added. If I would like to change something here, yeah, it's possible for reference node. So I can, yeah, change the geometry here. I can change the weld thickness, weld type, and so on and so forth. As you see, for members, as we are working with Checkbot and we imported the data from FEA software, I cannot change the position of it. So if I'd like to do it, I should do it first in the FEA software. And yeah, that's it for connection. Yeah, so I've load the template. I can save it, and just to show you, I will go on here. And for group 8, you see here the preview of my connection. And if I open any other node, so 153, this is reference node, and all the others, we call them child nodes. If I open a child node here, like 157, let's have a look at it, how it looks in connection. You see that same as for the reference node, I cannot change the position, but I cannot also change the model type, forces in, positions, and also the analysis type. Yeah, this is not possible. And if I scroll down to the operations, they are also in read-only mode. So that means if I would like to change the geometry, change weld thickness or whatsoever, I should do it in reference node. So this is how it works. But as you can see already, we have in this group 8 connections. So the previous workflow would be to open each connection and using connection library load the operations, but right now it's automatically propagated. So already here you can see that you can save a lot of time by utilizing these workflows. Let's so in short, yeah, why we're grouping the nodes, yeah, because you might ask yourself just to save time, to be more efficient when working with IDEA StatiCa. Let's proceed with the next point, and here I will switch back to my presentation, and let's talk briefly about this load extremes algorithm. So in Checkbot, but in connection as well, you can evaluate the critical load effects, how it works. Yeah, so in Checkbot, this option is a bulk variant of the function that is available in connection, and it evaluates load components of every connected member in the connection, and then selects the critical ones, meaning out of 60 load combinations, the software will filter them and say, okay, these are the critical ones. So it works real well, and I will show it briefly, but before we will do it, let me also show you one more thing. You see here these 2 links on the slide which we provided, and I highly encourage you to have a look at them, because there you will see a description of this algorithm, so how it works. Yeah, so here it's a description of how you can activate it, and then here it is you find a description of how it works. So what is very important here, what load is the extreme one, so you can see how the software is evaluating this. So for every connected member in the connection, we select most extreme ones based on these criteria. Yeah? And for example, it's like positive, negative, maximum of each load component, then maximum shear force resultant, maximum bending moment resultant, and so on and so forth. So I highly recommend going through this article so that you understand what's happening behind the scenes, because as I will show you in a moment, yeah, we can activate this function for group number 8. I will just click on this checkbox, and you can see out of 60 load combinations, the software tells me that for node 155, 3 of them are critical. For 157, also 3. So you see a high reduction of number of load combinations that shall be calculated. And what I suggest, what I recommend is you can use this option to quickly, efficiently design, analyze your connection And you can always, once you're done and you see that everything looks good, yeah, all the checks are passed, you can always at the end deactivate this function and then run the calculation for all load combinations if needed. Yeah, if you see that the checking engineer, for example, asks for that, you can always do it, but then you don't need to bother with opening, closing the connection, changing the design, because you've already checked it for the critical ones. One more important here thing before we will proceed is why I mentioned that article about what's happening behind the scenes, because I do not recommend using this option for footings. Why? Because with footings, as you've seen, what we are taking into account are the load effects. What we are not taking into account and what might be governing for footings are the edge distances, yeah, like concrete edge breakout might be the governing failure mode. That's why in this case, I would say I would rather here be careful and either calculate it for all load combinations, or if there are too many, I would prefer to have a look at the load combinations that have been selected, just to be sure that we are not missing the point, and so we do not have any surprises once we run the calculation for all 60 load effects. So let's proceed back to group number 8. As I mentioned here, it works well for steel-steel connections, and yeah, that was point number 3 of the workflow. We've evaluated the critical load effects. So right now we are ready to start the calculation. And again here, we can save time because as we have created this group, we can run the calculation for all of the nodes from this group. I just right click on this and select the calculate all option. You can also click here on this option. This is the same. And as you see right now, the nodes 153 and 54 are not deemed critical. That's why you will see also this note here that there are no loads on members. That means all load combinations have been deactivated for these nodes. And then 155, we see the results. Yeah, so this is the summary of the results that is shown directly here in Checkbot. You can see that the software proceeds 158, 159, 160, and that's it. So right now I've run the analysis for all the nodes in the group, and it took me, I guess it was around a minute to do it for this group of connections. And of course, as always, it's worth having a look at the results. Yeah, so let me open the node 156 here. Let me open it in Connection App, and then you will see that we can have a look at all the results that are listed there. Then once we've checked the results, then we'll proceed with further steps of that workflow. So right now we open the connection light up, and before we will jump to the checked up, let me briefly show you. Yeah, so here you can see the list of all the load effects that has been imported, and you see that only some of them are active. So these are the ones that the algorithm deems to be the critical ones, like for example here, this load effect number 50. And then we can jump to this checked up and have a look at the results. Yeah, let's check the plastic strains. Let's check the mesh. Yeah, if that looks good in deformed shape. So we can have a look at all of this. We can check the equivalent stresses, bolt forces. So all that you're familiar with from our connection app is here. Yeah, can be checked here. And also, that's what's something new in the latest versions is like you can, because here what you will see if you will go through tables, you will see the results for the governing checks. So for all of the load cases, but maybe you'd like to have a look at a particular load case. For example, load case number 32, sorry, load combination, I mean. just click here in the tree on that load combination, and then the results for that particular combination will be shown here in the table and also in the 3D scene. Yeah, same is for wells and balls. And if I say, yeah, that looks good, yeah, I agree with the results, I don't need to change anything because the code checks are passed, I can close this node and proceed with the next step of the workflow. But before we will do this, what I mentioned here is for the reference node, you are setting you are adding the operations and also choose which analysis step shall be run and what will come in the upcoming patch, because right now it is not possible to run backlink analysis here directly in Checkbot, but please wait another, less than 2 months. When the patch 25.1 is released, it will be possible to also run backlink analysis for the group of connections. And at the end of my presentations, I will also show you an alternative workflow where you can be, let's say, if you say that, okay, I like it how it works here in Checkbot, but maybe I would like to be more flexible, I will show you how you can do it by exporting node or nodes as an IDEA conf file and then opening it directly in Connection App. There you will be able to run the backlink analysis as well, and you will be more flexible with the reports, which I will show in a minute. Yeah, so that's it. Let me just briefly jump back to my presentation. And as I mentioned, this critical load effects algorithm, it's also available in Connection App itself. Let's talk about bulk report. Yeah, so this is also something that's new in version 25.0. We have an option to create a report for nodes that have been calculated directly in Checkbot. There are actually right now 2 predefined options. It's a brief and detailed report type, and I will just show you in a moment how you can do it. So you can select either all connections or just say, I just would like to create a report for reference connection, reference node of a group, and multiple report print options are possible as well. So let me jump back to our model here and proceed with group 8, because this is the only one that I have calculated here in this model. I will just select all nodes from that group and then go here to the report tab. As you can see, I can either create a report for all nodes or for selected. So right now I'd like to do it for selected ones only. And these are the 2 options that are possible. So the detailed and the brief one, I will just generate a detailed report for these 8 nodes. It will take a moment because, as you can see, it's generating right now 9 reports, but all of them can be then saved as one PDF or doc file. Yeah, so as I mentioned here, you are right now in version 25.05. It's only possible to have these 2 options, so the detailed and brief report. If you'd like to edit the report, then you have 2 options. So either you proceed with exporting the report as a doc file, and then you can use text editor like Word and adjust the report over there. Or I will show it after the Checkbot part. I will show you how you can export all the nodes from a group and then open them directly in Connection, and then you will be able to use the settings that are available in the report tab in Connection. So yeah, right now the software is ready with the report, so I can just briefly go through it. So as we mentioned, these 2 nodes have not been calculated because they are not deemed to be critical. according to the algorithm, and for all of other nodes, you can see the results being printed here. And then, yeah, we see the details for node 153, then node 154. As I mentioned, we have no results for that because they are not critical ones, but 155 is already a critical connection. That's why here you will see all the load effects that have been taken into account, the calculation, the unbalanced forces table, and then the summary of the results with detailed results for plates, then for balls and welds. So yeah, you can just go through it, have a look at it, and use this as an option in the software. And that was the report part. Let me proceed with communicating changes in connection design. So maybe you have received a CAD file, CAD model of the connection from your colleague or from an external office that has already modeled it in a CAD program. And maybe you found out that, okay, actually I need to change well thickness. I need to add stiffening plate. I need to change something in the connection. We all know, we've all been there, we've all done that. We know that yeah, writing comments, printing PDFs, it works, but sometimes it might be tedious, sometimes it might be error prone. That's why we have implemented the option of creating an IFC file in both Checkbot and connection apps. So you can export either all or selected connections and save them as an IFC file. Yeah, this file can then be used as a reference model in your CAD software, like for example, Tekla. Yeah, so you are just saving these files, sending them to the detailer, and thanks to the fact that we are retaining the original location of the nodes, it's easier to find out any clashes, any changes. So yeah, I think this is also something that can make your workflows more efficient. But yeah, how can we do that? Let me switch back to my model here, and I can do it again for the group 8 here. I can right click on that, and then if I go down, we have the option to export either one IFC file. That means all of these connections will be saved in one IFC file, or multiple IFC files. That means that these 8 connections will be saved as separate 8 IFC files. Yeah, the same option you can find in here. Yeah, you see this IFC and multiple IFC files. If I click on that, I can then find a directory when I want to save my IFC files in, then send this file to my colleagues. The other option that's possible as well, let me just take note 153, is using IDEA StatiCa Viewer. So this is like a free cloud tool that you can use, and if you're working with colleagues that do not have an IDEA StatiCa license, you can upload your connection and then open it directly in the browser. So let me just click on this button, and you can see that within seconds I was able to open it in the browser. So this is how the model looks like. And right now I'm already logged in, but if you're not logged in, then you won't be able to see all the details. So you need to have a login, but to use Viewer, as I mentioned, it's a free tool, so you just need a basic account. Nothing more is needed here. So it's like a free app that you can use. And if I click right now on the beam here, I can see it's HB 320 made of S355. Same here for the column. If I click on a plate, I can see all the details, yeah, with the dimensions here, with bolts being M20, yeah, and the holes being 22 millimeters. So if I click on the bolt assembly here, see it's M20 10.9. So yeah, this is how it works. The same is for welds. Yeah, for example, here I see that this is a fillet weld, double fillet weld, 6 millimeter thick, with the properties of S355. So this is how it works, and I've already spoke to many clients that are using it either to communicate the changes with the detailers, or sometimes also use it to communicate with checking engineers who'd like to learn more about their model in IDEA StatiCa. So this is how you can communicate. And for checking engineers, what is also very important is here's a full list of load effects that has been imported into this node, so they can also have a look at all these load effects that has been taken into account in your analysis. And as I mentioned, once you have saved it, you can click here on the share button, you can copy the link and send it to your colleague. Yeah, so you don't need to send files, you don't need to send them any instructions, just send them this link. Once they log in, they have the access to the tool in their browser. Okay, so let's go back to this to the presentation. So yeah, as I mentioned, these IFC files can be used also as a reference model in Revit or, for example, Tekla. This is what we've tested and what works longest. Yes, right now let's proceed to the last slide regarding Checkbot. So let's sum it up once again. So 158 nodes, load combinations, we have 60 of them in a model. And as far as I remember, it was like more than 75% of you saying that you will need more than 1 day to calculate all, to design all of these nodes. So here is a detailed table with average times that it took me for one group to activate the critical load checkbot, design reference connection, then batch design the group, and create a report for the reference connection only. So yeah, the critical load checkbots, this is actually, I guess, quite an easy one. Yeah, it takes actually even less than 1 minute for the groups. Then design of reference connection. Here, I assume that we know what we want to design. Of course, if you're not sure, then maybe that could take you a bit more time. But even there, if you're not sure of you or you need more inspiration, what I've shown today is the internal version of connection library, but there is also like cloud version or browser version of connection library where you can just take a look at over, I guess we are right now at 700,000 templates that you can use and download. So yeah, if you'd like to check it, you can see it in at connectionlibrary.ideastatica.com. Then batch design by group. Here it took me also about 5 minutes, but here, as in this model, I had different types of cross sections. It was rolled I section, but I also had hollow section. This highly changed the amount of time that's needed to run the calculation, because for hollow section, we will by default run the GMNA analysis, being like the geometrical material nonlinear analysis. And of course, this is a more sophisticated analysis, which is why it takes more time to run the calculation. For group with rolled I sections, it was around 1 to 2 minutes to run the calculation, because it also depends on how many nodes are part of that group. So here are many factors that can influence the final result, but as I mentioned, the average time was like 5 minutes for a group of nodes. And then creating the report for reference connection. You've also seen that in the presentation. So the total time here is 3 hours and 15 minutes. And yeah, I hope that this gives you like a good impression of what is possible in the Checkbot app, and I hope that this will encourage you to test the software, or if you're already experienced user, to incorporate this into your workflows so that you can be more efficient, so that you can have more time for the engineer part, for the creative part of your job, and so that you can automate the tasks that are, let's say, I don't want to say boring, but the tasks that can be automated without having an influence on the quality of your job. And before we will proceed to the last slide of the presentation, I also mentioned in the description of the webinar, during the webinar, that I will show you alternative workflow. So meaning, like, sometimes you might say, okay, I like how it works, but I'd like to be more flexible. Or for example, for this group, I would like to run stiffness analysis for one of the nodes, or maybe different type of analysis. So it's not possible right now directly here in Checkbot because we run the same analysis type for all the nodes from a group, but there is a workflow for that as well. So I can just take all of these nodes and save them as an IDEA conf file. Again, I can either save them as one file, meaning that will be one file with multiple project positions, or multiple connections. Connection file. So I've already done it I saved all of the nodes as one connection, and I have it open here. So here I'm working in a standalone connection app, and you can see here I have all of the nodes that have been exported. I see all of the load effects, all of them deactivated, but we can also talk a bit about this load effects algorithm, load extremes algorithm, that is also available here directly in Connection app. So if I right click on load effects, I can calculate load extremes here as well. But in this context, it works differently because here this algorithm takes into account only this one node. In the Checkbot, all of the nodes that are part of the group are taken into account. But this is also possible here. And as you can see right now, I have full control over all of the operations. So if I switch to node 158, for example, I can also change the geometry of the operation. So this is a trade-off for this workflow, but if you're done the calculation, then you can use it. If you'd like to change the geometries, the operations for all of the nodes from this group, I guess the easiest way would be to either do it in the Checkbot, or you can use connection library. So again, you could publish a template and then use the pause button to load that template to other nodes. And yeah, let's switch to the project tab right now. So I mentioned, for example, if I would like to run different analysis types for some of these nodes, how can I do it? So here you can see the list of all of the project items, and I can just copy the first one, maybe rename it to 153.1 or whatsoever. I can drag and drop, change it and move it here. And if I'd like to run the stiffness analysis, I can do it. If I'd like to run any other analysis type, everything is possible here, as well as backlink analysis. Yeah, so you can always here just activate backlink analysis for all of these project, all of these positions, and then click on calculate on to run the calculation for all of them. So this addresses the flexibility regarding the analysis, and regarding the report. If I go back, I can just switch to the report tab, and as you can see here, I have more options available. I can either generate the report for current position, for selected position, then you can see all of them are listed here in the tree. And I also have the option of setting these project items. So saying, okay, which drawings I'd like to include in my report, bill of materials, cost estimation, formulas, and so on and so forth. So here you have more flexibility, and this is the answer to questions regarding, like, what if I would like to have or change something in my report. So yeah, as I said, either you can save it as a doc file, or you can export your connections as IDEA conf file, open it in Connection app, and then all of these options are available to you. You can also see here that I can create IFC and IFCs files. So yeah, that was it, what I wanted to show you as an alternative to these workflows that are available in Checkbot. What I also like to mention, for those of you who've already tested the software in version 24.1, because this grouping, dynamic grouping, is something that we've implemented already in the version 24, you see that we've already developed it so that it's more reliable, so that you have more control over your designs, and we are not stopping. Yeah, so I can already tell you that the colleagues are working on making the option of aligning, for example, these beam members to assign them an eccentricity, so that the top flanges of both this member and these beams are at the same level. So things like that will come soon in the upcoming versions. And yeah, like I said, we are not stopping. There will be more. So feel free to test it. Feel free to check how it works today. And if you have any feedback or you'd like to learn more about this workflow, you can feel free to reach out to us and ask a question about it. So yeah, this is the last slide. As I mentioned, I hope that you are inspired to test it, to incorporate it in your daily workflows. And I hope that thanks to all of these functions, you will get more time to concentrate on the engineering part, the creative part of your job.
Thank you, Maciek, for your presentation. Thank you, Maciek, for your presentation. I will take over, and before we come to the Q&A, I just wanted to bring your attention to our support center, where you can find a lot of interesting and helpful information, as well as the recordings of all our webinars. So if you have missed this webinar, or if you want to review another webinar we already had, you can go there and you will find everything you need there. Next thing I want to bring to your attention is our IDEA StatiCa campus. There you can learn different, or you will have some courses prepared for different topics, steel as well as concrete. You can learn at your own pace. You can take the quizzes and just dig deeper into the topics. If you'd like, you can also get you certified. Just visit our website for the campus courses and check it out. Next are our upcoming webinars. On October 29th, we will have our international release webinar for the new version 25.1. Yeah, we will present all the new functionalities and everything that's new in the next version, and we will answer your questions. So just join the webinar to see firsthand what the new version is about. And another one is on November 12th. It's about parametric design of steel connections. So if you're interested, visit this one as well. Last thing, after this webinar, we will have a short survey. We would ask you to take part. It's highly appreciated. So if you have a few more minutes, please just answer a simple question and you will help us greatly. Last thing I want to say is the recording of this webinar will be in the support center and on YouTube in a couple of days. So if you want to rewatch, just check the website or YouTube to see the recording of this video. And now, we will turn on our webcams again so that you can see us. And Maciek prepared some answers to your questions, and I will give the word back to Maciek.
Thank you very much, Steffi. Yes, we have 3 questions to answer. I will share my screen again because I'd like to show you directly where you can find certain info. So let's start with question number 1 that comes from Mariusz. From what IDEA version this checkbot with grouping check is available? So as I mentioned, we've implemented it in version 24.1, but as I mentioned, every new patch, newer version, we are improving it. So I highly recommend using the latest version, which would be 25.0.5. Question number 2 comes from Marco. If there is an update in the original FEM model, how does Checkbot work? This is a very good question. So it's not that you are doing it once, yeah. So it's not the idea of this workflow. The idea of the workflow is that we are a structural data hub for the results, for the geometry, and so on and so forth. And once you've done with the calculation, but then something needs to be changed, like you need to add additional load effects, or you need to change some factors that needs to be taken into account right now. You don't need to start from scratch. Let me go back to this view exactly here. You can see that here we have 2 sync buttons. So either sync the current item, so you can actually synchronize the data between your FEA software or CAD software, but this workflow is mainly for FEA software, or you can sync your entire model. That means that once you've done it and you are, for example, updating load effects, then you just click on this button and then you can rerun the calculation here. And as I mentioned here, you can run it for all the nodes in a group. If you are changing the geometry, maybe then you need to update the operation as well, but I think that's understandable. That in this case, maybe in some cases it will work. It will always depend on, yeah, what is the difference between the previous geometry and the new one. But this is something that we are supporting with this sync functions. Okay, and let's go to the third question that comes from Daniel. Checkbot, does Checkbot work with Consteel software? Yes, it is. And for all other questions regarding if it works with program X, Y, Z, you can find all these informations on our webpage here, IDEA-StatiCa.com. Then here we have BIM and workflows, and here the direct link to supported integrations. So you can find a list of all supported software regarding steel, regarding concrete. Here you can filter it by FEA or CAD software. So you can just scroll through it and check if your software is listed here, and all that I've shown today is applicable to all of these FEA softwares that are supported. And it's also applicable to all codes that we are supporting. So this is like a code agnostic workflow that you can use in your daily practice. Yes, and I see that right now we're at the end of our of the questions that we received. If a question has not been received, you can count on us. We will reach out to you and send you the answer via mail. And as Steffi mentioned, after this session, there is a short survey. We'll be very happy to hear from you what kind of topics you'd like to see in the future, and if you'd like the content of this webinar as well. So thank you very much again for taking part in this webinar session, and we are happy that we are able to host another Connection Wednesday session from our German office. So greetings from Dortmund and have a good day.
Have a great day. Bye.